have two resistors of 2 ohm and 3 ohm which are in series. We also have two capacitors, 2 microfarad and 2 microfarad, which they are also in series, and there is a battery of 20 volt. We are asked what is the potential difference between the points A and B. Over here, as we see that these are the conducting wires, that is resistance is equal to 0, their resistance is equal to 0. So what's the potential difference now we see across these two terminals of the battery? The same potential differences across XY. Whether we consider this path, or we consider this path, or we consider this path, the potential difference is going to be 20 volt only. Now, as the capacitance of these two capacitors, that is same, both of them, they are of equal value, that is 2 microfarad. So the potential difference 20 volt, across this is 20 volt, so it means across this it is going to be 10 volt, and across this capacitor is going to be 10 volt. So if we take, that is, let's say the potential of X, that is potential of X, suppose it is V, we are talking the absolute potential for a time being, we assume, let's say its potential is, absolute potential is V. As we see, that is down this line, the potential shall be dropping. This at V, so this is going to be, potential difference is 10 volt, so this potential of A is going to be this minus 10, that is V minus 10. V minus 10 volt is the absolute potential of this point if we assume the absolute potential of X is V. Obviously, because these are capacitors, they block DC, they don't let the DC direct current pass through them, so obviously there will not be any current flowing through it. But over here we have also a closed path in which the current can flow. The conventional current shall be flowing in this direction from here to here to here to here, and it shall be flowing in this thing. Though there will not be any current in this upper arm, but the potential difference will be generated. If this is at V, so this is going to be V minus 10 volt. Let's look over here. Over here, let's say in this circuit, when we say potential difference across XY is 20 volt, and we apply V is equal to IR, where I is a current, be it over here, be it over here. If we say current I is here, the same current I shall be flowing in this arm only, because no current shall be going in this direction, because no current shall be flowing in this arm. So what's the current goes over here, conventional current goes over here, and comes back to the battery. So when we apply V is equal to IR, V is 20 volt, I we don't know, and resistance, both the resistors, they are in series 2 plus 3, that is we know when these resistors they are joined end to end, whatsoever current passes through 2 ohm resistor, the same current shall be passing through the 3 ohm resistor, so they are in series 2 plus 3, that is equal to 5, that is what we had been doing when we are doing resistances in series, we simply add it, so 2 plus 3, 5, so I comes out to be 4 ampere. If I comes out to 4 ampere, then certainly there is some potential difference across this 2 ohm resistor also. What is the potential difference across this? Is V is equal to IR. I is what? 4 into 2. That is potential difference across 2 ohm resistor is equal to I is 4 ampere into 2, that is 8 volt. That is potential difference across this is 8 volt. That is, if we say Vx minus, obviously the current is flowing in this direction, conventional current or positive current flows from higher electric potential to lower electric potential, so it means the electric potential of X is greater than the electric potential of point B, and the potential difference between the two is 8 volt. So that's why Vx minus Vb is going to be 8 volt. But what is Vx? Vx we have assumed that is equal to V only. So V minus Vb is equal to 8, or Vb is equal to V minus 8. That is the potential of B if we are taking absolute potential of point X as V. So we write it over here, Vb is equal to V minus 8. And over here we can easily see Vb is V minus 8, Va is V minus 10. So Vb is greater than Va. So Vb minus Va, if you are interested in finding a potential difference, we clearly see that is potential of B is greater than potential of A. Vb minus Va, that is V minus 8 minus V minus 10 is equal to V minus 8 minus V minus plus 10 is equal to, that is 2 volt. That is Vb minus Va is 2 volt. Vb is greater than Va, and the potential difference between this and this is 2 volt. We could have a different arrangement of capacitors, and over there then the potential difference across this and across this would have been different. Then also you can find what is the charge on each capacitor. We know that is when the capacitors they are joined in series, the charge on both of them that is same, and accordingly then we can find the potential difference. We have done these things when we had done capacitors in our earlier lectures. You can refer to that, and accordingly you can change some values, you can take some different values, and you can solve this question once again. Now what if there is a resistance of, let's say, 5 ohm added over here. Now if there is a 5 ohm resistor, we observe that current shall still be passing like this. It has got a closed path. But now the potential difference, that is the battery, has a voltage of 20 volt. Now the potential difference will not be 10 volt and 10 volt across these two capacitors. Why? Let's see. The current will be flowing in this direction, and the value of current is going to be governed V is equal to IR. That is, it has got a closed path. This is the closed path. So V is equal to I into R. We are using Ohm's law, where V stands for potential difference. So V is 20 volt. I we don't know. R is, now all these three resistors, they are in one path. 2 plus 3 plus 5, they are in series. What's the current passes through this? The same current passes through this. The same current passes through this. So it is 2 plus 3, 5 plus 5, 10. So now the current reduces to 2 ampere. Instead of 4 ampere, now it is 2 ampere. If it is 2 ampere, then if we have to find what is the potential difference across XY. So across XY, we use V is equal to IR. So V we have to find. I is the current which is flowing through this is 2 ampere. So 2 into the total resistance between X and Y is 2 plus 3, 5. I into R is 5. So it is 10 volt. It means now the potential difference between these two terminals, between these two ends, between these 2 points X and Y is not 20 volt but 10 volt, because if there is a total potential difference of 20 volt, some is dropped across this and some is dropped across this. Potential drop or potential difference across this is 10 volt, across this is 10 volt, 10 plus 10, that makes 20 volt. So now when the potential difference across this and this is 10 volt, it means once again the capacitors, they are of the same value. They are not of the different value. So what's the potential difference across this? The same will be potential difference across this. So if it is 10 volt, potential difference across XY, so potential difference between this and this is 5 volt. If we are taking the absolute potential of X as V, then absolute potential of A is going to be V minus 5. And across this 2 ohm resistor, if we find what is the potential difference, it is 2 into 2, that is 4 volt. 4 volt is the potential difference between the point X and B, X being at a higher electric potential as compared to B, because the conventional current, positive current, is flowing in this direction. Conventional current flows from higher electric potential to lower electric potential. So the potential difference between X and B is 4 volt. So we can say Vx minus Vb is equal to 4 volt. But what is Vx? Vx we have taken it as V. So V minus Vb is equal to 4. So Vb is going to be V minus 4. This is Va is V minus 5, Vb is V minus 4. That is, Vb is V minus 4. If you look at this, certainly Vb is greater than Va. So Vb minus Va, that is the potential difference between the two, is going to be Vb minus Va, that is V minus 4 minus V minus 5, is equal to V minus 4 minus V plus 5, and that is going to be 1 volt. So the potential difference between this and this is going to be 1 volt, and Vb is greater than Va, and Vb minus Va is going to be 1 volt. The potential difference between these 2 points is going to be 1 volt.